Hello all, good morning. Let us continue the session of e-content development, and the discussion today will go with MSP430 microcontroller discussion. Again, going according to the syllabus pattern, this controller unit comes under unit 2. The microcontrollers as considered stand as a brain device for any embedded system application. With respect to this, after the characteristic representation and after the applications of basic embedded systems, if the designer is intended to frame any sort of application in hardware, any sort of device in hardware, along with the peripherals, one of the major CPU device that is required for any hardware design with respect to embedded system will be the microcontroller. Out of the various popular microcontroller, if we start with basic 8051 8-bit microcontroller, plenty of microcontrollers are available in the market. One such most popular microcontroller is MSP430 microcontroller. And before going with the deeper discussion of this microcontroller, if a look over is presented according to the syllabus pattern, what we are trying to focus, the concept goes like looking over the features, family, versions of MSP430 controller, then architecture design of MSP430 controller, the inner look with the architecture and block diagram of MSP430 controller. Somewhere in the process, if we use the word MSP430 processor, then also the word suits to this device, saying like we are not considering any such element here as microprocessor. To make it very clear, in any embedded system we will be using the processing element as a microcontroller. So the word processor or controller used in the vocabulary or any representation will be much suited to the heading of microcontroller. So when we speak of learning or when we speak of knowing about any microcontroller or any microprocessor, things go in such a way like we will like to learn about the details of any controller or processor in two ways. One is through its architectural and block diagram representation, looking into the architecture, block diagram, seeing the arrangement, knowing the links between each block and registers, and then memory, then their bus connection, then their process flow will all be treated as one level of learning about any microcontroller and its operation. And the next level stands about learning any microcontroller or microprocessor. It's its programming model, looking over the addressing modes and instruction set, then trying to analyze what type of controller program is written with some application interfaces. Now this unit is focused on looking over the architecture and programming model of MSP430. Then in continuation we'll be looking over with some basic level interfaces as mentioned in the list there. We'll be looking over some LED and switch operations along with some other peripheral interfaces. Now going with the meaning of this microcontroller, it stands as MSP430. Here MSP stands with the name mixed signal processor. If we speak about the processor mixing of the signal, is very simple to understand. It goes as mixing of analog and digital signals. Both signals are being entertained in this processor design. Again, I use the word, though I am mentioning the heading called as processor, we will stick on to the name. It is purely a microcontroller. Now on the screen what we see is a list of features about a microcontroller called MSP430. Whenever we start to study about the any microcontroller or microprocessor, we will first look over the overview or basic requirements in the design of the microcontroller, or what we call basic features of any microcontroller or microprocessor. As mentioned here, we see the features of MSP430, 8 features listed in the arrangement. If we consider the basic feature that we should know about any microcontroller is its designation. Our microcontroller selected here is MSP430, stands as a N-bit microcontroller. The N value that is been represented for our microcontroller here is 16-bit. 16 here stands the ALU capacity, or in very rough language we consider it as number of data bits that our microcontroller is going to handle. So MSP430 is a 16-bit microcontroller, and it has an addressing bit capacity of 16-bit, through which we can represent up to 2 power 16 locations in consideration as 64 KB of memory. Then as it is a microcontroller, it will be having some inbuilt features like interrupts, timers, and clock frequency generators. So with respect to microcontroller MSP430, we have some more specific arrangements considered as low power modes, which are used to regulate the power supply and save the energy of MSP430 to improve its efficiency. Then we will have different clock provision models. We'll look over all the things in the coming architecture and discussions over clock and power modes. Now, one more point to focus with respect to the features of MSP430, they are being represented in the first point as it is a 16-bit RISC CPU following the von Neumann architecture. So in general, the divisions are made in two ways, like Princeton or von Neumann architecture. Another kind of architecture that is represented will be Harvard or non-von Neumann architecture. Most basically, the differences are already known, but still we would like to highlight, like in von Neumann architecture, we will be having a common bus for both data and program memory. In non-von Neumann architecture or Harvard architecture, we will be having separate buses for both program and data memory. With respect to this, again, it will be having some subdivisions in this architecture design, saying like von Neumann might be having two other supplement arrangement in the architecture design considered as CISC and RISC. Non-von Neumann or Harvard architecture again could have its own division considered as a CISC and RISC. Here CISC is treated to be complex instruction set computer. RISC stands for RISC, which is again termed as reduced instruction set computer. The consideration is not with respect to the complexity or count of the instructions. Here it is based on the design feasibility. The design feasibility, like some of the features called major feature called pipelining, major feature called scoreboarding, major feature called parallel processing. All these are some backups, these are some push-ups that we can find in RISC architectures that stay back in the CISC architecture. So considering the design as per the provision given to MSP430 is a RISC CPU working under von Neumann architecture model. Now with this few things which we move on, we could look over another major arrangement with respect to MSP. If we had some idea about 8051 microcontroller developed by Intel Corporation, ultra low power facility is provided with respect to MSP430. Earlier microcontrollers used to run around 5 volts of DC. This microcontroller runs around 3.6 volts DC, and it can be formulated up to 1.8 volts DC based on some enhancements in the versions. So if we look over the different versions we are providing with MSP430, it is having a good family arrangement. Most of the famous versions provided in MSP430 are G series and F series. One of the most learning or educational purpose series which is popularized in the market is MSP430 G2553 series, where G here stands for gain version, F here stands for flash. Another we will be having as code memory version considered as C series. Anyhow, based on some arrangements, internal sophistications, like basically MSP430 will be having an inbuilt provision of A to D conversions. So if we have more number of A to D converters within the architecture, the version will be different. If we have inbuilt drivers of some other peripheral communication, we will have a changed version. If we have a faster code memory inbuilt present in the architecture, we will have this F series arrangement. In educational purpose or in practice purpose or in beginners purpose, it is suggested we work on MSP430 G2 series. One of the versions selected for the discussion stands as MSP430, name of the controller, G stands the version, 2 stands the improvement in the version, then 553 is the code, or any sort of improvement could be provided, like 552 could be earlier version, 553 could be a later version, maybe we have 555 also in the coming versions of MSP430. So in continuation, after the features, if we look over the block representation of MSP430 processor, it will be having all the provisions that a general microcontroller architecture possesses. Now we can see a block diagram of ALU. Whenever we start to learn about any architecture, it is preferred that we learn or we trace out where is the ALU inside the architecture of this microcontroller or microprocessor. So if we look over the left side of the architecture, here we have a 16-bit CPU arrangement considered to be the ALU brain of the CPU present in MSP430. Connected to this is some clock system. Now we can see some good names around the clock system arranged there, considered as MCLK, SMCLK, ACLK. It will be treated as master clocks, sub-master clock, and auxiliary clock. How these are being designed and how they work and how they support the CPU operations is a part of our discussion. Then we can see master clock is directly connected to CPU. The major clock that is connected to the CPU will be the oscillator clock frequency of MSP430. Actually, MSP430 runs on a clock frequency of 16 megahertz to 25 megahertz. The maximum frequency will be provided by the master clock, and it is directly given as a provision to the CPU. Along with this, with some inbuilt provisions for dumping the programs, having some connections through external peripherals. We have some more arrangements in the setup saying like analog to peripheral connections, flash arrangements, ports, IO ports, interrupt arrangements, and all the provisions will be basically given to the MSP430 processing architecture. If we go with the basic design, how MSP chip appears to us, these are some of the arrangement. So if we just speak about the ports with respect to MSP430, a version shown on the screen to us is MSP430 G2 series, which is a simple 20-pin architecture sometimes, and it can have a lower version of 14-pin architecture. If we have more IO ports, we are increasing the architecture pins. So according to the given series here, we have 2 IO ports in provision with respect to MSP430, and they are titled as port 1 and port 2 in simple. The arrangements of the port pins are being represented in the diagram. They are not in a sequential way. That is a point to observe. Now we can see on the left side of the pin diagram, P1.0, P1.1 up to P1.5, we have the provision from pin number 2 to 7. Then if we look over at pin number 8 and 9, we have some other provisions of P1.6 and P1.7 respectively. In the same version, if it is extended a bit, the pin numbers are being brought down, and we can see pin number 14 and pin number 15 in N2 series, N20 series of MSP430 are being provided for P1.6 and P1.7. This extension could help us in adding one more port for the operation. Port 2 is utilized in total for the discussion. Now same port 2 pins are also not in an order. They go in a U-shape arrangement as mentioned. P2.0 to P2.5 shown in a U arrangement from pin number 8 to pin number 13. Then we can also see the multiplexing of P2.6 and P2.7 with pin number 18 and 19 in the later version. Now arrangement is also being classified with respect to the clock arrangements, power supply arrangements, and ground arrangements. Pin number 1 is a supply arrangement where we can have a provision of maximum of 3.6 volts, and still a low power can also be operated with our MSP430 processor up to 1.8 volts of DC. Then on pin number 20, we can see the ground arrangement VSS. In this description, what we focus is how a general MSP430 arrangement is represented. Now, if we have a quick glance on the inner structures of memory inner structure of MSP430 design, we could see the memory space 64 KB of allotted memory, out of which some space is allotted for peripheral interface registers and RAM, then a code memory called flash. In continuation, when we speak, there are some support registers with respect to MSP430 CPU operations. Most popular names, they go with heading called processor registers. Out of this processor registers, some registers can also be used for multiple operations. As mentioned in the list, each register with respect to its data and address capacity will be 16-bit of size. So the register count is also mentioned as R0 to R15. Totally 16 general purpose registers are being present, out of which few registers are parallelly or multiplexed in another format to be used for addressing purpose also. Some of the names like program counter, a register which holds the address of the next instruction, then stack pointer, a register which holds the address of the top of the stack. Then we have a status register, the register which indicates the contents present in a flag register. Flag register is used as an indication to tell what has happened in the CPU very recently. Then we can see the inner contents of this register, starting with the known terms like carry, then 0, then negative stands for N, sign bit, mostly sometimes shown as yes, now it is shown as N here. Then we have GIE, global interrupt enable arrangement. Then we have oscillator sharing, we are using complete clock or we are using little bit clock. Then we have CPU sleep mode arrangement. Then we have a constant generator arrangement continued with overflow arrangement. Most of the bits of MSP430 flag registers are reserved. Here constant generator is a representation to show it will be helping in adding few more instructions directly representing with the registers. Instead of giving them with any separate memory location, we can directly give the increment and decrement operation with respect to the data without going for any addressing mode representation. In continuation, after the discussion of memory arrangement and register distribution, we can see an overall look of how the inner inner biopsy of this ALU and register connections could be mentioned. The most prominent flag bits that get affected with the CPU operations are shown on the left side of the ALU block, shown as 0, carry, overflow, and sign arrangements. Then, if we go with some more inner parts of MSP430 architecture, one more facility that is given as, apart from interrupts, we will be having timers. One of the most popular timer, or if we speak if we raise a question like how many timers are there for MSP430 general model, we can see 2 timers. It will be mostly timer A, and timer B is sophisticatedly used in higher versions. Right now, if we speak about the basic version, we will be having only timer A, whose facility or whose performance or whose duty is as simple as to count the time step operations carried out by the microcontroller. It may also have some facility of raising the interrupts, a request to the CPU that whatever allotted duty it has performed its operation. So what about the other timer that is most popular with respect to MSP430 or any other design is a timer which helps the microcontroller to operate the sleep mode functionality. One such good name we have is WDT. The name of this timer is watchdog timer. What happens with respect to watchdog timer is whenever the processor or controller or ALU is stuck in some long executions or in non-resulting executions, or sometimes if the CPU has entered into a sleep mode and some operations are getting waited to be executed, then the duty of this watchdog timer is, as by its name, its duty is to watch the CPU. It goes and activates the CPU, telling that please come back to your active state. This happens in a technical way based on some time constant. So according to the design given for the watchdog timer, at every 32 milliseconds, the watchdog timer have to go to the CPU and invoke it back to its active state. So this is a duty given by the MSP CPU ALU itself. Every 32 milliseconds, CPU should reset this. If it is not getting reset, it will go to the CPU telling that you have not come to reset me, so maybe you are inactive, kindly invoke yourself. The duration around for sleeping to a CPU will be 32 milliseconds. That is the duty of this timer, else its only duty is to count the sleep time for our microcontroller. In continuation with some more physical arrangements provided with the architecture functions for MSP430, we could look over the different types of clocks. This is one of the unique facility provided to MSP430 processor. So in general, clock distribution with respect to other microcontrollers is very rare. With respect to MSP430, it could be focused very clearly. Wherever it is not required to utilize the total clock, the system will deviate the clock arrangement. So it is being represented as shown in the block here as master clock, submaster clock, and auxiliary clock. Those peripherals which need a high speed of operations, and we know the answer, like one of the most high speed arrangement in the microcontroller device will be only the ALU or the CPU representation. No other device connected to the CPU will have greater speed than the CPU speed. So either it will be having an equal speed or lesser speed compared to the CPU speed. So if we don't require that much of clock, it can be divided. It is being shared according to the divisions that could be provided. And the next clock that we see here will be submaster clock, which could be divided based on the requirement. It is not as same as the speed of the CPU, but it is not also very low. A medium level clock. Around, if we are using 16 megahertz as the top frequency, something around 4 megahertz could stand as the submaster clock. So minimum it can go from 1 megahertz to any sort of division. Auxiliary clock mostly will be in kilohertz. It will be very much useful for the remote application peripherals which require very less speed, and those interact the CPU using some interfaces. This division is also been represented in this pattern as what will be the physical arrangements that are required to generate various clocks with respect to the master clock. If we activate every peripheral which is working on oscillator operations, we will be utilizing the maximum frequency. If not, many of these connected oscillators will be kept in sleep mode, will be kept in mute mode, or will be hibernated. So this method of hibernating the clocks, this method of reducing the clock's utilization, we consider them as power saving modes. So how many such power saving modes we have? We consider them as 5 power saving modes. Including the active mode, we will be considering as 5 power saving modes. They are treated as low power modes. So we will be having 5 along with one more, totally 6 power modes, out of which one is a very normal mode considered as active mode, and all other remaining 5 will be standing as low power modes for MSP430. Something that is mentioned on the representation here is, in active mode, every device, every peripheral will be having its own arrangement for operation. So every clock arrangement will be active. Whenever we use no such power savings, we consider, or whenever the CPU it is utilizing every resource it wants to operate, we consider it as active mode. In remaining conditions, we can see some of the clocks are being relaxed. So low power 0, low power 1, low power mode 2, low power mode 3, or LPM 4, low power mode 4. Some of the clocks are disabled and few clocks are being enabled. Based on the strategy of their disabling and enabling arrangement, these power modes are being described. Now in the discussion, whatever it is presented so far, we have looked over the architecture, block diagram, timers, registers, and some peculiar states like low power modes. These are some of the things that make MSP430 more commercialized or increase its commercial value in order to save the power. Now, at this part, we complete the session with half of the learning procedure for any microcontroller or microprocessor. We mentioned like one method of looking over the arrangement with respect to the design is learning through its architecture model or block development model. In the coming class, we shall continue with the programming model of MSP430. Thank you for this.